we are going to see about indexes. So index helps to quicken up access. It helps to make the access of the column fast. So this is like an accessing a book's index. So by accessing a book's index, I quickly reach on to that particular page. Let's see on chapter 7. I quickly reach the chapter 7 instead of checking on each and every page. So it index here is a separate data structure that stores a sorted copy of the column values that are there. So the column values will be sorted and then it will store the copies, and then it will maintain the pointers to those rows, and that will help to ensure fast lookups without scanning the entire table. So here there are two steps: sort the column values and maintain pointers to the actual table rows. It will maintain pointers to the actual table rows. So there are various kinds of clusters. I use indexes so that I reduce the IO operations, I minimize the full table scans, and I also accelerate join, order by, and group by. So indexes will help me to speed up the reads, but they will also impact writes. So when it comes to insert, I must update all the relevant indexes that are there. Update indexes on modified columns will need rebuilding. Delete also index entries must be removed. So index will help with read, but writing will be impacted because due to necessary changes needed in indexes. Due to necessary changes needed in indexing while writing. So with the help of indexes, I will avoid full table scans. I can quicken up join, order by, group by. I can reduce the IO operations. So we use indexes whenever we want to do frequent search columns, join conditions, whenever we have columns like where, order by, group by, and wherever we have high cardinality data. When not to use index, we should not use index, not to be used with one, small tables, if there is frequent updation that is needed, low cardinality columns. No, low cardinality columns means like for example gender will be male, female, or others. So now here it only does not have too many unique values, so for that also it need not be used. Then there are infrequent columns, rarely used columns. For those also indexes should not be created. Now let us see what are the various types of indexes. So the types can be clustered, which is for our key column. Then there is non-clustered, then composite index. So these are the various types of indexes. So the first one is clustered index. Clustered index, there can be only one clustered index per table. So the first one is clustered. Only one clustered index per table. And it is usually created on the primary key. Usually for primary key. Like for example, here I can say cleared clustered index. The name of the index on posts and ID is the column. So now as we can see here, one clustered index is already created for the post, which is for the primary key. I can create a non-clustered index. Let me create a non-clustered index for name column. So clustered index is for the primary key. Then we have the non-clustered index. Now non-clustered index can be many, and it is for non-primary key. Also to speed up the access. So here I can create a non-clustered index like this. The third one is composite. Now the composite index can be clustered or non-clustered. It basically combines two columns. So here can be clustered or non-clustered. It combines two columns and it can be specified something like on ID comma name, and let me give it the name post ID. So composite cluster. So like this it can be created. Clustered index is only one per table, whereas non-clustered and composite can be any.